Hello, in today's video, I'll be showing you how to find quadratic functions by analyzing graphs. In this video, we will find vertexes, x-intercepts, y-intercepts, domain, range, interval of increase, and interval of decrease. Our first problem is y equals x squared plus 4x plus 3. In this problem, a equals 1, b equals 4, and c equals 3. Our first step is to find the vertex, which is x equals negative b divided by 2a. We can substitute b and 2 for 4 and 1, which will give us negative 2, which means x equals negative 2. We can then substitute x for negative 2, which will give us negative 1, which means our vertex is negative 2 and negative 1. Because a equals 1, a is actually larger than 0, which means that our vertex is the minimum point. If you cannot remember how to do this, just draw the graph using the vertex and 2 points before and after the vertex, or complete by squares. We can then find the x-intercept, which is when y equals 0. So if we solve this, 0 equals x squared plus 4x plus 3, we will get x equals negative 1 or x equals negative 3. For y-intercept, when x equals 0, we get y equals 3. Our domain is all reals, and our range is negative 1 is less than or equal to y, and y is less than infinity. Our interval of increase is negative 2 is less than x, and x is less than infinity. Our interval of decrease is negative infinity is less than x, and x is less than negative 2. The next example has y equals negative x minus 2 squared plus 9. If we factor this out, we will get y equals negative x squared minus 4x plus 4 plus 9, which equals out to negative x squared plus 4x plus 5. In this example, a equals negative 1, b equals 4, and c equals 5. To find the vertex, we substitute b and a for 4 and negative 1, which gives us 2. And if we plug 2 in, we get 9, which is our vertex, 2, 9. Our vertex is the maximum point because a equals negative 1. Which means that a is less than 0, which means that the vertex is the max. We then find our x-intercept. By using 0 equals negative x minus 2 squared plus 9, we get x equals 5 or x equals negative 1. We then find our y-intercept by substituting x for 0, which gives us y equals 5. We then find our domain, which is all reals again, and then we find our range, which is negative infinity is less than y is less than or equal to 9. We then find our interval of increase, which is negative infinity is less than x, and x is less than 2. Then to our interval of decrease, which is 2 is less than x, and x is less than infinity. The problem before can be solved in a different way. In this example, if we have a number in parentheses, plus or minus another number, we can see that x will equal 2 and y equals 9 in this problem. The vertex is x equals 2 because it's inside the parentheses, and the y is 9 because it is outside. The vertex is the maximum because it is less than 0. Our x-intercepts are x equals 5 or x equals negative 1 like the other problem. Our y-intercepts are y equals 5. Our domain is all reals. And our range is the same as last time, which is negative infinity is less than y is less than or equal to 9. Again, our interval of increase and our interval of decrease is the same. Thank you for watching my video.